We want to, good morning, class. We want to start now. To apologize for starting late. This is the class for DCS216. That is computer hardware and software maintenance 2. Now we will be introducing operating system. Operating system. And it is very important that we listen. Uh, so I quickly share my screen. Make sure you have registered on Module, and the link to this online class is there. And I've asked the class rep to put it also on your WhatsApp group so that anytime you have me on your timetable, you just connect. We'll wait for some 15 minutes to allow people to gather, and then we start immediately. So make sure you have registered on Module. All the course materials are on the Module. This will just be our interactive session, and we should be able to get acquainted with the online lecture series and practical series. Okay, I'll be sharing my screen now. So just what shall be introducing. Okay, let me quickly introduce the course. Let me introduce the course briefly. This is DCS 216. DCS 216. Yes, I believe you can see my screen now. This is DCS 216, and it is titled Computer Hardware and Computer Hardware Maintenance and Repairs 2. Computer Hardware Maintenance and Repair 2. And as we earlier mentioned in the first semester, that hardware and software are very closely related. So this second semester shall be focusing mainly on the software component of the computer system. So we have told you that computer system is actually a system, and it cannot work without all the interacting parts properly functioning. So now we are talking about the things you should expect in this course. We'll be introducing operating system, and we'll be identifying operating system's functions, structure, and component. Also, we'll be looking at major system files of the operating system. This will include input-output.sys.system, boot.ini, sorry, the win.com in the earlier Windows, ms-dos.xyx, that is 6, and then we have all these then we're going to have what do you have it? Let me try to minimize it, or let me try to expand it. Okay, it's not showing everything. We see autoexec.bat, config.sys, just to show you the previous file systems that have really helped us to arrived at the current operating system development. We also need to understand memory management. We need to understand um, we need to understand command prompt, procedure, and syntax so that we can perform operating system maintenance uh, with command prompt, uh, with specific commands that will help us. We also have understanding file system. Okay, now you need to understand system files and file systems are different thing entirely. So you have to understand the difference between them. Uh, we have the system files, we have file systems, and we shall be differentiating between them. Then we need to understand Windows registry. Windows registry is very important. Then we need to also we're going to do some installation procedure for Windows XP just for being backward compatible. Then probably Windows Vista, Windows 7, Windows 8, and Windows 10. If we can just do Windows XP, and then just for you to know the old Windows versions, and then we can also look at Windows 8, and then Windows 10. Windows 8 and Windows 10, they are very close. And so, as time will permit us, uh, we want people to, we want the students to be familiar with what has happened earlier so that they'll be able to key into the new uh, development. Now, there is need for caution uh, in this course. You must be willing to do, uh, you know, self-learning because of the current situation. We're going to perform operating system upgrade, how to do that, optimizing and maintaining Windows, troubleshooting and fixing Windows problems, and then we also look at few of advanced troubleshooting skills, and then how to prepare for international certification in computer maintenance for those who really are interested, who want to go beyond the classroom and fit into the community of IT professionals. Then we look at IT professional ethics. In our labs and practical session, we'll be having all this installing OS, Windows XP 7, 8, and 10, as I've mentioned. We'll just select uh, two or three of these because of the time factor. We're going to look at how to upgrade operating system, create emergency boot disk or repair disk or system repair disk as it may apply in any of these operating system versions. Identifying basic system boot sequences, boot options, and recovery options. That is actually when you want to solve problems on Windows operating system. Using system restore, recovery, uh, recovery disk cleanup, defragmenter, and running antivirus. You need to know how to do this, how to use the system information utility to diagnose your system. Also, we're going to look at DirectX diag as a utility to diagnose your system and to know what needs to be done. MS Config, Microsoft Config also is very useful, and others. We're going to see how to update and maintain Windows. Regular updates come up, and we have patches, we have updates that you need to know their relevance. Then we want to install and run Microsoft Virtual PC uh, for virtual machines and all that. Then installing drivers and optimizing Windows, very, very important. Troubleshooting and fixing Windows problems. These are important labs that we need to look at. But as I've earlier told us, that uh, both lab and lecture are interwoven. They are closely interwoven. So you cannot miss lecture and think that lab will cover up. You need to be able to combine the two because the theory will give you a leverage to be able to understand the practical. So I'm going to quickly start with the first one. Quickly today, we'll look at today's introductory lecture. I'm going to look at introduction to operating system. Introduction to operating system. Now, operating system, very, very important. We need to understand that operating system is very, very critical to computer system. And just like if you want to be a successful computer scientist or computer engineer, you need to really understand operating systems. Because if you want to drive a car, but you don't understand its engine, transmission, and other systems, but why can't you just use your computer? Why can't you just write file writing program? Now you need to understand these complexities behind the operating system so that you yourself can become a system programmer or you can find yourself in any other uh, any other field or any other area of computer uh, and IT specialization. So quickly we'll look at overview of operating systems. Operating systems are a collection of programs that give a computer the critical functionality that lets you use it for work and entertainment. So an operating system is actually a collection of programs that gives a computer the critical functionality that lets you use it for work and entertainment. So this uh, this material is for you to have an in-depth knowledge of it, of what computing systems. I'm going to be using a slide very soon, but just go through this. Here you're going to see what is a microcomputer. We're going to see, we have talked about this in the hardware lectures in semester one. Now, these are the things you can review, run BIOS, all these things, and the types of microcomputer that are being used today. We have the personal computer. We have all these. This is an example of BIOS, what BIOS, and we have desktop and laptops. All these are just the foundational knowledge we need to have. We have servers, we have handheld devices. All of these they use operating system. So quickly, I want you to know that there are various operating systems that are in the market and that you need to get, you know, yourself familiar with. Uh, but we have a lot of them we'll be talking about in this course. Now, let's quickly look at functions of operating systems. You know, we need to know the function of operating system, and I'll be summarizing this. Whatever operating system you are using, whether it is Windows 7, Windows XP, Windows 8, Windows 10, and whatever version Windows. We'll also be working with Linux, Unix, we'll be working with uh, other kind of operating system, uh, even the one on smartphones, like Microsoft Windows Phone and all that. you know, represent they are that are designed specifically for smartphones, include Google Androids, Palm WebOS, Apple's iOS, and Windows Mobile, and others. So these are smart mode of operating systems. So, but for the laptop and desktop, they are more expanded. So, one of the things you should take note of when we talk about operating system uh, functions. Number one is user interface. From this diagram, you can see user interface. I believe you can see this diagram very well. Um, you see user interface. You see um, uh, okay. Now I want to be sure that you are seeing my screen. User interface. That is the first contact any user will have with the operating system. So it depends whether it is command line user interface or graphical user interface. Command line deals with keyboard typing of commands, while the graphical user interface deals with your mouse and the icons that you see on the screen and clicking them and all that. So very, very important. Then uh, we have task management. We have task management, and we have device management. We have memory management, trying to link all of them together. We have security. We have file management, how you save your file, how you open your file, how you know, keep track of your file. Um, then we have job management. Uh, these are operating system functions. Now let's quickly go a little bit uh, in depth. Now, the user interface is that software layer, which is sometimes called the shell, through which the user communicates with the operating system. There must be a way to communicate with the operating system. And the operating system also will communicate with the computer. That is the hardware. And so the user interface includes the command processor, which loads programs into memory, as well as the many visual components of the operating system. As you see, what you see when you look at the display. So all these are the visual component. We call it them the graphical user interface. Now, when you have a computer running DOS or Linux without a graphical shell, this visual component consists of character-based command line that provide only sparse amount of information. So that is what we call the command line interface. And then you can see an example here. Also, uh, when you want to become uh, proficient in command line interface, you need to memorize some commands and you need to be able to understand their functionalities so that you can use them. We have also modifiers and subcommands that are needed, especially when you want to become more of an expert. But as a computer scientist or computer engineer, you need to learn the command line interface, because you need to, you're not only a computer user, but you want to be a computer uh, maintainer, a computer repair personnel. You want to maintain the computer system, you want to solve problems when they arise, and you want to be more of a support um, personnel. And so you need to go higher than the ordinary user. So in that case, we talk about the super user. So you will be regarded as a super user because now you need to know more than the ordinary users. So that's why we will be doing a lot of command line operations. We have to be interacting with the PC, with the computer system, with the command line so as to solve problems with operating system. Now, if you on the other hand, just want to, be ordinary user and you are comfortable with only using the system, um, you need what it just may need to know is the graphical user interface, which is fully integrated into the operating system. If you are working on Microsoft Windows, you are working on Apple Mac, but if you are working on Linux and dogs, disk operating system, you need, that is of Microsoft also, you need to be well familiar, well acquainted with command line interface. Now, when you are working with graphic user interface, it covers a lot of things that can make using computer a lot more easier. A lot easier. We have menus and graphical icons that allows you to just point to a particular icon and select program to run and perform another task, such as opening a word processor file, what we're opening a PowerPoint slide, and all that. So, although you do not have memorized commands when you are working with graphical user interface, but you need to learn the meaning of the various graphical pieces that will make up the that makes up that make up the graphical user interface. And you'll be able to know how to navigate among these pieces to find your programs and data. And so you need also to learn how to make a program become active to start it running so that you can get your work or your game done. When you are playing a game or you're doing work, this has to be activated before you can actually use them. Now, that is all about that. Then we also have uh, job management. It's one of the important aspects of um, one aspect of operating system. It is a function of the operating system that controls the order and time in which programs are run. Which programs are run. Job management is an operating system function. Uh, is already embedded in the operating system, but the major function is to control the order and time in which programs are run. We have two examples of programs that may perform these functions are a scheduling program that schedules other programs or batch files to run on a certain day and time, and a print program that manages and prioritizes multiple print jobs. So these are examples of programs that can fit into that. Now you can see an example here. This is an example of a typical GUI. We have already shown you, this is an example of a Microsoft disk operating system prompt where you see this blinking um, line, and that shows that is where the first character will appear when you start typing from the keyboard. Now, then we have talked about job management. This is what you see on the screen now is the typical GUI screen of Windows 7. It's Windows 7, and you can see a lot of things here. Now let's go to task management. Task management is an operating system function found in multitasking operating system. Now we'll be talking about different kinds of operating system. We have single task, multitasking, multiprocessing, and all that. So a multitasking implies that a computer is simultaneously running two or more programs or tasks at the same time. So task management will need to be involved. Task management functionality of the operating system will need to be called for this uh, aspect when you have to run two or more programs at the same time. For instance, on my system here, um, multitasking is already, you know, uh, playing out. I'm running a Zoom application to do the presentation online. And also, I am on the web. I open, Chrome browser, and from there I'm able to log into the module where I'm calling these files, and so I'm already multitasking. So I'm already using more than one program at the same time, and also um, um, I'm also doing a recording of this. So this is just multitasking. Multitasking. Now, in reality, a computer cannot run more tasks simultaneously than the number of processors that exist within the computer. That is in reality. But recently, we begin to see most desktop and laptops computer having more than one processor. So, but before then, we only have single processor. Even though we are now having dual core, core i3, core i4, core i5, and core i7. Now having different cores on the single physical chip. So when you have a single processor, switching between tasks so fast that it seems that you are executing a number of tasks at the same time. And so that is what is happening now. Because when you have a single processor, a task management that will have to handle that. And even on new processors that can have multiple principles within a single chip. So they have true multitasking. New processors that can have multiple CPU within a single chip, as I've mentioned, Core i3, Core i5, Core i7, and dual core, all those, they can have true multitasking. Each of the processor can be handling different tasks and then at the same time. So task management controls the focus where the system's attention is at any given moment. That's what task management actually does. It allows users to switch between, it allows the user to switch between tasks by giving the focus to the application the user brings to the foreground. That's the work of task management. In Windows, this application runs in the current window, and the window that is on top of other windows on the screen, that is the current window. The current window is the window that is on top of other windows on the screen, and that is the current window I'm using now. And the window that receives input from the keyboard when user types, that is the current window. Like now, my mouse is moving, so this is my current window. And that is all about task management. Now, we'll talk about memory management. Memory management is an operating system function that manages the placement of programs and data in memory. It manages the placement of programs and data in memory. I believe you are following me. Now, why keeping track of where it put them? So, memory is normally, as I normally explained in my class, memory uh, can be can be likened to your spreadsheet, like Excel. You have the cells, and you have the column, the rows with the cells. So each of the cell can be a memory location. And there, you see, there is a function of person that have to manage this. This has to be managed. It has to be managed. And is to keep track of where this program and data in memory are stored, are kept for future retrieval before the power goes down. So the moment, don't forget, when the power goes down uh, and the memory does not have any power to back it up, like a laptop, like phone, even if it's a desktop without UPS, everything in memory will go. We talk about volatility. That means memory is volatile, that it can easily lose its content. So as long as power is present, memory management is to place programs and data in memory and keep track of where they are. Now, in the case of advanced operating systems such as Windows XP and later vision Windows version like Windows 7, Windows 8, Windows 10, and uh, and the others we're expecting very soon. This involves a scheme for making optimal use of memory. It involves a scheme making use of uh, of making optimal use of memory. You see, to make sure that memories are not, uh, poorly used, and the virtual memory will be introduced where more code and data to be memory, which allows more code and data to be memory than what the actual physical system memory can hold. Okay, we have what we call the physical memory, which is the physical RAM stick that is plugged into the motherboard. Okay, then we have virtual memory, which is actually a part of the storage device, either your hard disk or your solid state device, that will now be used to augment the physical memory. And so we'll be talking about this in practical time, during the lab time. You will discover that virtual memory are very, very important. They actually keep what will be needed intermittently. I mean, between operations, between computer operations, between memory operations. And so virtual memory, they actually help to augment or to add to the physical memory. So virtual memory allows more code and data to be in memory than what the actual physical system memory can hold. Using a memory management operating system component called the virtual memory manager, it's very, very common now. This operating system, they move code, they move data, and they also uh, 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 move instructions, to a portion of the disk defined as virtual memory. That's what I'm talking about, virtual memory. That is a portion of the disk that is to undo inter, you know, intermediary operations before they are committed to the RAM. That is for the physical memory. Meaning that this disk space is used as if it were memory and not just disk storage space. So the virtual memory that is created on the disk so that code, instruction, and data can be moved before a final result of a process is gotten. And this will be normally on the disk space, on the disk of your system. And it will be used as if it were memory, as if it were the RAM. So that's why we call it virtual memory. And the disk is used as if it were a memory, a RAM, not just disk space, disk storage space. So the operating system performs this transfer for code and data that are part of any program that currently does not have the user's attention. You see, because this unneeded now information does not have to be kept in RAM for immediate use. And so other programs that do need the use, that do need to use the memory now can do so. While those that may be needed later will be kept in that virtual memory. So this is very important. And this is what actually makes memory management very, very effective, efficient. And it actually speeds up the overall performance of the of the computer system. So memory management function may not be included in every definition of an operating system, but a very important function. It's a very important function, especially in the Windows, Macintosh, and Linux operating system that we have in this write-up, in this book. Now, we have the next thing is file management. File management. Don't forget, we have talked about uh, user interface, job management. I've talked about tax management. We're talking about memory management. Now we're talking about file management. Now, file management refers to as data management. Is an operating system function that allows the operating system to read, write, and modify data while managing the logical storage of the data. Each operating system has at least one scheme of logical organization called its file system. Now, take note of that. File system is the logical structure used on a storage device for the purpose of storing files, as well as the code within an operating system for the purpose, I mean, that will allow the operating system to store and manage files on a storage device. I take it once again. A file system is the logical structure used on a storage device for the purpose of storing files, as well as the code instruction within an operating system that allows the operating system to store and manage files on a storage device. So the way files are stored and managed on hard disk, on flash drive, on solid state device, all these uh, uh, are being handled by file management functionality of the operating system. It also talk about data management inside the operating system, different from the other data management in database. Now, the logical structure is written to a storage device when an operating system uses a technique called formatting. So before you can have a file system in operation, it must have been the disk to be used, either hard disk or flash drive, must have been formatted, prepared to handle the files and codes. Now, the OSM maps the logical organization of the file system to physical location on the storage device, as we talk about, we talk about this as we talk about cylinder, we talk about sector, we talk about tracks, as we refer to um, um, disk management and all that, and storage devices. So what it does is that the operating system will map the logical organization of the system of the file system to physical location of the storage device, so that it will be able to store and retrieve data. The logical structure of a file system also stores the metadata, which is data about the store files. When that's in Windows and DOS and that, we talk about file system, a file allocation table, FAT32, FAT16, and high performance file system, and NTFX, new technology file system or network file system, and then we talk about all the other ones that are available. Yes, here. We talk about Mac OS file system. We talk about, in Linux, we have X2, EXT2, EXT3, GFS, VFS, and Racer FS for Linux, and we have PC-DOS, and we have FAT system, file operation table file system, that came with PC-DOS and Microsoft DOS, and then for other file system, we can learn more about that. Um, Example of file system for optical media include ISO 9 or 9660. We also have universal disk format UDF file system for optical media. That means CD, DVD, and the rest. Then file system for sharing files over a network are independent of the file system used on storage media. So they can be a little bit confusing, but they are different. So not just such network file system um, include uh, you know include NFS, used by Mac OS, Mac OS X, that means Mac OS X operating system, and Unix, and Samba, SMB, and SIFX used by several other operating systems. So that is about file management. So it's a bit more complex. We're going to be taking that in file systems. We talk about file systems, and that will be a topic on its own, so as to enlarge and expand on what we have here. Uh, Actually, in the file management, that's what we talk about. Uh, Files, and we talk about partition. We talk about folders. We talk about directories. And these are that contain files and as well as other folders. So this is how file management allows users to organize their files using other special files, such as that act as containers. So we'll be learning more on this. Now let's move to the let's move to the next one: device management. Very, very important. This function controls hardware devices by using special software called device drivers. Now, this is one aspect that maintenance personnel, maintenance engineer, or system repair persons must be very familiar with, because there are times that the problem of the system will be the driver. The hardware may be working properly, but the device driver is misconfigured, um, or badly installed, or whatever it is. So you need to know how to deal with device drivers. So device management is what handles that. It is one that controls the hardware devices by using special software called device drivers, which are installed in the operating system. Device drivers are unique to the device, and the manufacturer of the device creates them to work with a specific operating system. So a sound card, we have a device driver, and a video card, we have a device driver. A camera, web camera, we have a device driver, and a mouse, we have a device driver. And so for each of the operating system version, so that means the DOS mouse driver may not be to work with the Windows 10. Also, the VGA or video driver for DOS will be different from that of Windows 7, Windows 8, Windows 10. And the same thing with Linux and Unix operating system. And then we also have Mac operating system. We also have Apple Macintosh, as we talked about. Now, all these things. So device are what we're talking about is that device drivers are unique to the device, and the manufacturer of the device creates them to work with a specific operating system. For instance, a printer or video adapter will come with the drivers for several different operating systems. Yes. One device driver will not work with Windows 7, work with Windows 8, work with Windows 10, or work with DOS, or work with Windows Vista. So it will be different. And also for the printer too, the printer driver for HP, we need to be written for each of the operating system: Windows 7, Windows XP, Windows 10, Windows 8, like that. So what he's saying is that the device driver contains the commands understood by the device, and uses these commands to control the device in response to requests it receives from the operating system. So what we are stressing here is that you need a component-specific device driver for each unique hardware component with which the operating system interacts. So device driver is very important in the maintenance of any hardware, laptop, desktop or servers. Device driver are very important. We need to insert drivers to correct problems here and there, and network cards, the needs driver, sound card, needs driver, what have you, CD-ROM drive, every device that you have, keyboards, they need drivers. So we're going to be looking at that in the practical lab. Now, we'll move to the security. Last of it, but not the least, is the security. The security function of an operating system provides password protected authentication of the user before allowing access to the local computer and may restrict what someone can do on a computer. Now, this is very, very important for confidentiality and for protection of our valuable information. For example, Rachel is accounting clerk and he has confidential information on her computer. She doesn't want just anyone to be able to walk up to her computer and access them and take them away. And so he needs to set up her computer so that anyone getting to it must log on with a username and password for a user account. The same thing is also applicable in network operating system. A user account is nothing more than a name and a switcher password stored inside a PC. So security is a large topic, and we know that. So we cannot we will need to take many books and weeks if we are to really master that. So there is different aspect of security, but we're just looking at the very basic level of username and password. We have a lot of, when you talk about network security, computer security, so many things will be involved. And that we will touch briefly. But you need to know that you can learn to be a security personnel. You can be a certified, um, you know, security personnel, or what we call the hackers, or uh, call them, well, white hat hackers, and they are actually what we call the those who are employed to secure system and network. Uh, they are given permission to do that, and they go through specialized training and certifications. So this will be covered uh, later. Now, quickly, let's talk about categories of operating system before we round up this lecture series. Categories of operating system. We have operating systems that can be, right now, we can categorize operating systems into 4 categories, 3 of which are based on the number of simultaneous tasks and the number of simultaneous users that can be served at the same time. So while one category is real time, it's based on an entirely different set of characteristics. So we have 4 categories of operating system. Number 1, single user, single tasking. Single user performing single task at a time. Then we have single user multitasking. Single user performing more than 2 or more tasks at the same time. Then we have multi-user multitasking. Multiple users being able to perform more than 2 or more tasks at the same time. And then we have real-time user, real-time operating system that interacts with the user on real-time basis. Uh, these are more sensitive. Quickly, I will rush through because of my time. I need to start rounding up now. I will not make the video to be too long so that it can be followed and digested before the next video. So a single user, single tasking operating system is one that allows only a single user to perform a single task at a time. Okay, so that has been settled. Then single user multitasking operating system that allows a single user to perform 2 or more functions at once. That is single user multitasking. Microsoft Windows, Macintosh operating system, they are in that category. The previous one, example of single tasking operating system are Microsoft DOS, Palm OS, and Palm One handheld computer. Now, we have multi-user multitasking. This allows multiple users to run programs simultaneously. So they run multiple users, run multiple programs, multiple tasks simultaneously. Such operating systems have been existent for decades on mainframe and now on today's network servers, sometimes called terminal servers. Now, this is not at all the same as connecting to a network server for the sake of accessing files. Now, they will be operating at the same time. So when a computer connects to a file and print server to access document file, the processing work can be performed locally. So, but when a multi-user is being, it will be performed on the server. So, with a multi-user server operating, we give each user a complete operating environment on the server that is separate from all other users, and they can run multiple programs. So that is about that. So quickly we'll move to um, all the multi-user operating system that we have: Windows 7, Windows XP, Windows Vista, Linux. They are all multi-user multitasking. Now let's move to look at this example here. Example here can serve as, okay, you can see an example here. This let me minimize it so I can see. You can see this is a terminal server and all this. So this is an example of a multi-user multitasking. In the early days, we have some of them that we have installed even in the center here. Now we have real-time operating system. Real-time operating system is very fast and relatively small OS. It is often embedded, meaning it's built into the circuitry of a device and not normally loaded from a disk drive. So real-time operating system runs real-time application, and it may support multiple simultaneous tasks, or it may only support single tasking. That's the major different characteristics. It may support simultaneous tasks at the same time, or may just be only one single task for the purpose of speed and effectiveness. A real-time application responds to certain input extremely quickly, thousands or million, thousands and millions of a second, milliseconds or microseconds, respectively. So they run medical diagnostic equipment, life support systems, machinery, scientific instruments, and industrial systems, and they are time dependent. That's why we call them real time. So time is very, very critical. So real-time operating systems are used in aviation, in aerospace, where the code must run within the allotted time, and they must not miss that allocation of time schedule. So output must be provided in time to make a course correction or to make a decision in the case of aviation software, or make a flow correction in case of ventilator, or provide a warning to an operator, or to help to know the situation of the life of an individual on life support system. So this is very important. So example of real-time operating systems include Blue Cat, Linux by Linux Works, QNX, Neutrino by QNS Software Systems, Operating System Embedded, OSE by I mean PXOS, and Windows CE. So real-time embedded systems are everywhere now. Device with real-time embedded system can control the movement of surveillance cameras suspended by cables over a sport arena. We have motion detector motion detection cameras now. They are being controlled by real-time uh, you know operating system. Other devices that gather data from race cars and transmit the data and live video images on the race car from each car. Real-time embedded systems are also used in unmanned military ground vehicles, and also you find them in very large-scale machines such as huge sack, parcel, and large parcel sorting machines that are found in the U.S. Postal Service bulk mail center. In summary, a real-time operating system speed, bit of work with special real-time application defines it. That's just it. Now, we also have what we call the 16-bit, 32-bit, and 64-bit operating system. As you can see, this has to do with the number of bits they can handle in their addressing capacity and their processing capacity. So we call an operating system that can take advantage of the addressing and processing features of the processor an X-bit operating system. So this start with 16-bit. The original Method DOS was a 16-bit OS, and the same thing as was Windows 3.0. It's and its sub versions. Windows 95, Windows 98, Windows Millennium, they are all 16-bit. With mostly 32-bit pieces, but some 16-bit pieces for downward compatibility. Okay, so Windows 95, Windows 98, Windows Millennium were real hybrids. Okay, they have 32-bit pieces with some 16-bit pieces for downward compatibility with the previous version. Windows XP had a 64-bit version, but it's not widely used, and you're unlikely to encounter it in the field. Now, the Windows version, Macro S and Linux OS, because they are both available that we are discussing, uh, and I will be discussing, they are both available in both 32-bit and 64-bit version. All things being equal, 64-bit version will be faster than its 32-bit counterpart. But the bigger difference between the 32-bit and 64-bit version is in the address space used by both the system RAM and other RAM and ROM in the computer. So that we need to differentiate properly. Windows 64-bit will be able to do a lot of things, does not use the maximum theoretical address space of 64-bit CPU, which is 2 raised to power 64 or 9.2 quintillion. That's 9 followed by 18 digits. That's how it's supposed to be. That's about you know 9. That is quintillion. It's more than trillion, and like that. So this is what you have for memory, memory limits. You have Windows XP Professional, 4 gig, 32-bit version, 64-bit version, 132, and the rest. Just have a look at that in the material given to you on Moodle. Okay, so we're going to stop here uh, so that you can digest this, and then we'll give room for questions in the next class. Thank you for your attention. We'll be stopping here today, and you need to know more about all we have. Read more and make a contribution. Uh, Thank you very much for your time. Um, Thank you very much for your time. We shall see in the next lecture. Thank you very much.